Hi, I'm Paul. We're doing Leetcode must-know interview questions. Today's challenge is reverse nodes in K group. We're still doing linked lists. This challenge is rated as hard. It's similar to the last one we did, which was the challenge. What was that one called? Reverse linked list 2. The input to that was a linked list and a left pointer and a right pointer. So the task was to reverse the section of the linked list between the left and right pointers inclusive. Okay, this is very similar, except that we're going to reverse as many of these things as we can. We may reverse multiple segments of the list. Well, let's read the challenge. Given the head of a linked list, reverse the nodes of the list k at a time. All right, k is also an input, integer input. K is a positive integer. It's less than or equal to the length of the linked list. If the number of nodes is not a multiple of k, then left out nodes in the end should remain as is. You may not alter the values in the list nodes, only nodes themselves may be changed. I want to make sure that I understand this. Oh, okay, yeah. Number of nodes is n. K is at least 1. N is at least 1. Can you solve this in O1 extra memory space? I hadn't thought about that. I mean, it's probably O1. But yeah, okay, so like this one here. Example 1. The list comes in as 1, 2, 3, 4, 5. K is 2. So we reverse the first 2 nodes, giving us 2, 1. Well, actually, it would give us 2, 1, 3, 4, 5. We still have more than 2 nodes left, so we can reverse another set of 2 nodes, the 3 and the 4. After that, we don't have 2 nodes left anymore. So the final is 2, 1, 4, 3, 5. And I think this is similar enough to yesterday's problem that I can probably save some typing by just bringing in yesterday's solution. This is reverse linked list 2. I'm going to take that and paste it over here. I mean, I don't want to oversimplify it, but I think some of this is going to be usable. So, where are we here? If head.next equals null, stay safer with it, and blah, blah, blah. No, I don't need that right now. And left equals right. Well, there is no left or right in this one. And the head.next being null, I think we're going to handle. So, you know what? We can probably just take this out. The dummy node. We still need that. We need that because we need a pointer to a node before the first node that we're going to reverse. List node, node before reverse, we still need that. Okay, in this case, it's guaranteed to be the dummy node. And current, do we have a current here? Yes. I'm going to copy this. Current, I don't think it's going to work like this exactly, where we set this to the first reversed, which is the node after node for a node before reverse, because I think we can reach a situation where well, current is dummy node. You know what? I'm not sure. I'm not sure. I'm just more confident that we don't even, you know what? We don't even have first reversed yet. So let's just set it to dummy node. That'll work. All right. This is where we loop through the list to find left. We don't have left, right? So let's replace it with this. While current dot next not equal to null. It's possible at some point in this loop that current dot next will be equal to null, but it's also possible that we will jump out of the loop, as you'll see here in a minute. I mean, current dot next would be null if the length of the list is a multiple of k, because we reverse everything, and eventually we current dot next would point to the end of list pointer. If that's not the case, we're going to jump out early. So let's make sure that we have enough nodes left to reverse. So we'll say for I equals 0, I is less than k. I need more than that. I is less than k, and current is not equal to null. That is, we have not reached the end of the list. I plus plus, and within that loop, we will increment current. So we're going to loop through there k times and make sure that we don't hit the end of the list. If we hit the end of the list before we go through k times, we don't have enough. We don't have enough nodes to reverse anymore. So if current is equal to null, then we're done, and we're going to return the head pointer. Dummy node points to the head pointer, so we'll return dummy node dot next. All right, what is next? I don't think we need any of this anymore. I'm going to take that out. Okay, sorry if I'm stuttering here. I'm kind of making this up as I go. We can't really do this in a for loop anymore, because the for loop was fine when we had left and right, and we knew how many times we had to go through it. In this case, the for loop is not appropriate. There is no more left and right anymore. So what we want to do, we can still do this. Let's know temp equals current dot next. Okay, so current, because we went through iterating with current now points to the last node that we want to reverse. And current.next points to what would be the next series of nodes that we want to reverse. We need to save that because we need to reconnect the reversed sequence to the list, and we also want to know where to pick up and reverse the next list. So save current.next because we're going to change it. We're going to change it to null. It becomes an end of list indicator, meaning it's the end of the list that we're going to reverse. List node, okay, we need a like, oh, what can we call that? I don't think we have anything in here that's analogous to that. Well, let's do this. List node start equals node before reverse next, right? Oh, wait, we didn't. Did we get a node before reverse? Yes, we did. Okay, so node before reverse is now the dummy node. It points to the head of the list. So for now, yeah, that'll be fine. So list node start equals. First time through, it's pointing at the first node. All right. Node before reverse next. I think it would be easier, since this is something that we're going to potentially have to do multiple times, to say that node before reverse next, which points to the segment that we're about to reverse. Let's just call it in a method. We'll write a method. Assume that we have a method that reverses a list. If we give it a list, or if we give it the head of the list. If we're going to give it the head of the list, we also have a null pointer at the end of the list, an end of list indicator. So reverse a list, and is going to reverse the list beginning with start. Okay. What else? Start. Oops, I need that. Start dot next, and start, after it's been reversed, is at the end of the list. So start dot next is going to equal next dot temp. We saved that because it represents the node after the sequence of nodes that we reversed. So we're connecting it back into the list. Equals next temp, node before reverse. Okay, now we've got to start over. So node before reverse, node before reverse is going to equal start, which is the last node in the list that we just reversed, and current is going to, well, we could say current equals start, or current equals node before reverse. So is that consistent with what we did at the beginning? Node before reversed was the dummy, and current was the dummy. So that is consistent. Those are pointing in the same place. Current equals next temp. That doesn't make sense there. Actually, something looks off on these brackets. I do not want to close the while loop there. Where is the cursor? Oh, there it is. I don't want to close the while loop there. This all needs to potentially happen. multiple times. All right. After we go through this, assuming we're able to reverse the list, we now have a node before reverse and current, which point to the node before the next sequence of nodes that we have to reverse. Potentially. If there's enough nodes, we'll reverse them. But we're going to go back up to the top of the while loop and see if we have enough nodes to reverse. If there's enough nodes to reverse, we'll reverse them. Eventually, we'll get to the end of the list and stop. Or, yeah, I mean, we might stop because we hit the end of list pointer down here, or we might stop just because there aren't enough nodes left and we'll jump out. In any case, if we do drop out of the while loop, we still want to return dummynode.next, which is the head pointer of the modified list. Okay. Oh, you know what? It's right here. I could have just, but this stuff we don't. Well, actually, we did need that. No, we don't need that. I'm going to take this out and then we'll write the reverse list. We'll write the reverse list. It's going to be very similar to. It's going to be very similar to what we're doing here. So let me review this again. List node, next temp. All right, save the temp. That points to the next block of nodes. Set the end of list pointer for the list that we want to reverse. Get the start of the list, which will eventually be the end of the list, and reverse it. Reconnect it into the list, reset the pointers. All right, good. In that case, let's do this. This could be a private method. We're just using it as a helper. It's going to return a list node, and we can call it reverse list. It's going to take as input the head node of a list. All right. Let's say previous equals null, and current node previous equals null. Yeah, that's actually what we were doing yesterday. I probably should have kept that and just moved it down here. List node prev equals null initially because there is no previous node yet. List node. I guess we can call it cur here as well. That will be the head pointer. You don't really, if you get a head pointer, you don't want to mess with the head pointer if you're going to use it for iteration. Just keep the head pointer, and we'll use that for iteration. Okay, we'll say while cur is not equal, not equal to null. Well, we have not hit the end of the list segment that we want to reverse. Okay. We actually want to do this, right? Let me paste that in there, see how it looks. All right, list node next temp, yeah, is current dot next. Yeah, okay, we're reversing it. Okay, we got to save that because we're going to start reversing the pointers. Next.temp equals current.next. Are these, let me check these tabs. Okay, that's fine. No, why does it go there? Let's see. We'll go end. We'll go here. All right, that's good. Current dot next equals previous. We're pointing it back to the previous node. First time through, previous is just null. That's fine because the first node is eventually going to be the last node in the list. We'll change the pointer to hook it back into the list. Previous, and we're going to advance these. Previous will now equal current, and current will now equal next. All right. Is that going to work? I mean, let's look at these. Let's say we have this list sequence, 3 and 4. It comes in, we have a head pointer, 2, 3. Previous is null, current is head. Current is pointing right here. While current is not equal to null. Actually, the next pointer, 4, is null. Save the pointer to 4. Set this to null. Set previous to 3. Set current to next temp, which is 4. All right, so current is now 4. While current equals is not equal to null. Is current equal to null? No. All right, so next temp, we will save the next pointer. That actually is null. Current next equals previous. Previous is now 3, so 4 is going to point back to 3. Previous will point to current, which is 4, and current will point to next temp, which is null. While current not equal to null. Okay, so we're done. We're going to return this. 4 is now going to point to 3. 3 is going to point to null. We've got a reversed list, and when we get that back right here, start dot next. Start dot next. Start is now 3. It's at the end of the list. Start dot next equals next temp. We saved that. It points to 5. Okay, reset the pointers, try again. What we'll find out is we don't have enough nodes to reverse anything anymore. Okay, so on this one, what are we going to return? Well, as we go through this, we find that at the end, prev is going to equal, wait a minute, what do we want to get back from it? Reverse list, start, node before reverse, next equals reverse list start, yes. Okay, so node before reverse, before we reverse that, node before reverse is 2. So we want to, I'm sorry, it's not 2 because we already reversed it. It would be 1. We want it to now point to 4. As we go through the reverse list, by the time we end it, prev points to 4, current points to null, so we want to return previous, which is 4, and we'll hook 4 up at the beginning of the list. All right, let's put that in. Return previous. Okay. That's all I can think to say about it. I'm going to try to run it. See what happens. I knew I couldn't get through all of that without a typo. Line 27, semicolon. Okay, try it again. Another compile. Oh, Here we go. Line 19. For int I. All right, try it again. All right, base case is accepted. Let's move this over a little. Bring the frame over here. Submit. Cross our fingers. And we have good runtime. Good runtime. It actually spread out a little bit this time. And what did it say? Can you do it in like O of 1 space? That is a good question. I mean, let's go to the memory. I think this is O of 1 because we're not using any extra space. I mean, we're not creating any extra nodes, so O of 1, yes. All right. So that is I forgot what it's called already. Reverse nodes in K group. I hope you enjoyed it. Please feel free to like, subscribe, comment, and see you next time.